Hello, everyone, and welcome to the SourceForge podcast. Thank you for joining us today. I'm your host, Bo Hamilton, senior editor and multimedia producer here at SourceForge, the world's most visited software comparison site where B2B software buyers compare and find business software solutions. Today, we're talking with Steven Umbehocker, founder and CEO of OSNexus, a leading provider of software-defined storage solutions. They make the QuantaStor STS platform, which really is all about simplifying the management of complex storage systems across on-premises, cloud, and hybrid environments. The platform is deployed by Fortune 500 companies, addressing a broad set of storage use cases, including everything from server virtualization, big data, cloud computing, and high performance computing, among many others. We are really in the information age. I think we're transitioning into the intelligence age with all the AI automations going on. And the core foundation, I think, that really defines this era is data, which needs to be stored, it needs to be accessed, shared, and protected. And I think that's a good segue. That's where OSNexus comes in. So to talk more about OSNexus, let me introduce Steven Umbehocker. Steven, welcome to the podcast. Glad you can join us.
Thanks for having me. Great to be here, Bo.
Awesome. Yeah. So OSNexus, I just want to jump right into this. OSNexus, it was founded in 2015, right as sort of the transition to the cloud was really starting to, I would say, peak. Imagine you could go back to 2015 or maybe the years that preceded. What motivated you to start the company, and what were some of the problems in the industry that you were trying to solve?
Yeah, actually we got our start in 2010. So
Oh, wow. Okay.
this month today we're 15 years old. And when I started the company, uh, it's actually there's a lot of things that haven't changed, and that is around a lot of storage systems these days are still very proprietary platforms. They are running on customized hardware. They add a lot of expense to environments. And I was kind of looking at storage and compute and seeing how the compute revolution with VMware, some of the other hypervisors, just everything ran on x86 servers. You could just take any servers, group them together, and have all your compute. But the same wasn't the case with storage. Everything was still really dominated by big players like EMC and NetApp. And the idea was, hey, let's go and make a storage hypervisor. This was before the term software-defined storage was coined. And so I kind of thought of it as a storage hypervisor. And we started building the software to just be able to run storage everywhere and be able to support those virtual machine workloads. I was previously working on Zen Server over at Citrix and was running into all kinds of scenarios where the security features of the storage platforms were just insufficient to kind of integrate properly with the compute environments with virtualization environments. And so actually it was the security aspects that were some of the big driving factors, both the openness and the security features. And so the company name itself, OSNexus, means open storage nexus. It's really all about bringing a nexus of open storage technologies into a unified platform.
Oh, I love that open storage or open source Nexus. Okay, that at my main 9 to 5 is senior editor over at Slashdot, and we love everything to do with open source software, and I think that's really huge, and that's really neat to know. I didn't know that, so that's cool. Now, so you mentioned these problems that were you were faced with in the industry. They're ongoing. So you created the QuantaStor software-defined storage platform. How would you best summarize this product and just explain to customers why you'd want to utilize it?
Yeah, QuantaStor basically bare metal installs onto a server or a virtual machine and turns it into a storage system, a storage appliance, and then it combines together either in pairs to do highly available scale up clusters or in 3 or more servers to do scale out. And organizations today, they need all 3 types of storage: file, block, and object. Those are the primary 3 storage protocols that are used. On the object side, S3, block is iSCSI, Fiber Channel, and NVMe over Fabrics, and then file is NFS and SMB. And so we created a platform that does it all. So instead of having to buy 3 or 4 different products, you can just use QuantaStor and then build out the storage across what we call a storage grid. And the grid technology really solves a big challenge, which is how do you keep track of everything? If you go and deploy a system in London and another one in Seattle and another one in New York. How do you go manage that as one thing? And our grid technology links all of the systems together across all the sites, so you can globally manage all of your storage through that grid technology. And that technology is built into every appliance. So it's not like some extra software that you have to install. The systems, as you deploy them, you just link them together. You click some buttons in the web UI to add additional storage systems, QuantaStor systems into the grid. And now you can fully automate and manage everything through a single pane of glass. So that distributed management, kind of elimination of storage silos that are hard to track, and being able to automate and manage everything as one, and having the ability to do all the major protocols, file, block, and object. That's what really differentiates it, and it just makes it so that organizations can build out to over 300 petabytes of storage in one grid. So we really focus on organizations that need to be able to scale rapidly and scale to large clusters over time, and the ease of management of all of that. So yeah, the platform's got a lot of advantages, and then of course it runs on any x86 server. We work really closely with Supermicro and Seagate so that our software gets bundled with their hardware. So we have a number of pre-canned options, but we also work with all the major server vendors like Dell, HP, Cisco, and others. So customers can kind of bring their favorite server platform into the picture and use that for all of their storage systems.
Interesting. Okay, so yeah, you can kind of mix and match, so to speak. That's a great kind of breakdown. I think it's always great to get a summarization of your product before we kind of delve into more of the technical aspects. I would say in the simplest of terms, the platform you guys offer, it, just for listeners, to kind of reiterate this, it separates the software from the hardware in the storage system. So the software can work independently, right, and control any hardware the company chooses. I think where it starts to get a little bit more complex is where you're talking about maybe the scaling up component, QuantaStor scale up and scale out architecture. Could you kind of break this down some more and talk about how it works to maybe address some of the challenges companies face when scaling their storage environments?
Yeah, that's a great question. When we're looking at a particular storage challenge that is of a scale that's under a few petabytes, then we will typically do a scale up design. And the reason why is the scale up configuration only requires 2 servers, so the cost is lower, but it also has some performance benefits and a few extra feature benefits as well in those smaller configurations. Like, we can auto tier those to object storage in the cloud. So files that are not been accessed frequently, you can have those automatically migrate to your object storage bucket and free up local space. But yeah, the scale up configuration is a 2-node HA failover type architecture that's like common to a lot of traditional SANs like the NetApp and other products. So you take any 2 commodity x86 servers plus any some number of attached disk storage chassis, and which can be NVMe these days, or like the Seagate makes an entire line of JBODs that we integrate with, but we've got a broad HCL of over 100 servers and JBODs that we integrate with. But those 2-node clusters are very compact, and so they're very low cost. And another example is Supermicro makes a cluster in a box unit that has 60 drive bays that all fits in 4 rack units, and it has both servers and all the drive bays in there. So you can start really compact and small at a very cost-effective price. But then we go to the other extreme with scale out. With scale out, you can go and build over 100 servers in a single cluster, and each node of that cluster can have multiple petabytes of storage. And that's how we get to the scales of tens of petabytes and hundreds of petabytes. So for, you take a look at some of these university environments where they're getting data from telescopes and other sources that are producing, terabytes per day, petabytes per month. They need that ability to scale to the tens of petabytes very rapidly, and that requires a scale out architecture because they're typically using really large file systems and or a mix of that with object storage. And so we do both. The same software does both. It's just configured differently. And to get QuantaStor onto the server, you just burn the ISO image to a USB stick and plug it in and install it just like any other operating system. It's all Linux based underneath, so it works with the broad spectrum of servers that are on the market.
Interesting. Okay, that makes it you make it sound super easy.
Yeah, it is. The installer, you basically can mash the enter key 3 or 4 times, and the whole system's installed. It'll ask you, what to apply some IP addresses to your network ports, but beyond that, it's everything else is just automated in the install. And then after the install is done, the box boots up and it will show you the assigned IP address, and you just go to the web interface to configure the rest. So a lot of systems out there, they're really command line driven. They're complex to go set up. QuantaStor, you can use the CLI and our APIs to configure things, but the web interface you can do right from the beginning and set up the entire cluster and storage grid just through the web user interface in minutes. So we really focus a lot on ease of use, because when I started in the storage industry back in the late 90s, there were specific roles for storage administrators where it was a full-time job just managing the storage. And large organizations, banks, they still, and other large organizations, they still have dedicated people that just manage storage day in, day out. But for the vast majority of the industry, IT people have become generalists. They're required to know networking and virtualization and containerization, and storage, and they do all those different aspects and security management, all as part of their job. And so it's super important to make it as easy as possible to go set up and maintain, and so that you can sit down and go provision some file storage, provision some block storage in just a couple of clicks and be done. And what I found in the early days, and even today, there's just this complexity to a lot of the storage products that are out there where you really, there's just way too much in the ones that are command line driven. There's just way too much risk in terms of doing a typo and doing something wrong. And the ones that have user interfaces, they're just overly complex when people are just trying to do this as one of their tasks during the day and not just have to go and get a PhD in storage. They want to be able to just get in and get out and have it do the right thing. So that's kind of a big focus of what we do as well, is trying to just make it easy to manage storage at scale by IT generalists and not just the experts.
Yeah, that my mind is just kind of wondering there with it made me think of the Napster and LimeWire years where I would just be kind of burning discs in my bedroom, and just the ease of use, kind of surrounded with the ISO files. And a little bit off topic, but that's a really that's a huge component, just making it easier to scale up, and also retain the security aspect too. I think I'm a big picture guy. A lot of this is very technical. So I would just kind of, again, summarize the scale out architecture you guys have. I would just picture it's more concerned with adding more storage hardware to increase the total capacity and performance of the system, versus the scale in is concerned with optimizing what's kind of currently being utilized, right? Now, how does this help? How does your platform help organizations manage and store their storage systems across like a diverse set of industries? I think of the healthcare, energy, media. You mentioned the universities; they all have their different needs and requirements. Do you offer a one size fits all solution, or do you kind of cater your solution to the specific industry a client is working in?
Yeah, we really cater it to their exact workloads. What we're looking at here is the QuantStore scale up design utility, and we have two major kind of hardware designs that we use: the scale up and the scale out. The scale up design, you can see here, it has 2 servers with some attached disk chassis, and the utility's got a bunch of different vendors in here. So if you wanted to take a look at a 2U design from using one of the Seagate dual node servers with the Seagate hardware, or do that with the Supermicro. You've got that flexibility to try out and see what different designs look like from different hardware vendors. Here's an example using Dell servers with some Seagate 106 bay expansion chassis, and you can just adjust the capacity to whatever you need. So if you need 6 petabytes, you just put the amount in there, press enter, and it will update the design.
Oh, wow. That's cool. That's great.
Yeah,
And you have the summary onto the right of all the different tech specs.
yeah, it gives you some some capacity numbers, usable capacity, and then you can change the layout of the data here and say, hey, I want to use triple parity, and you can see it reduce the amount of required hardware. You can change the hard drive size. We can go up to a 24, and that will also reduce the amount of drives required. So this is how we have a good consultative discussion with customers. Once we kind of narrow in on what type of storage, like scale up, hybrid, or scale out, all flash, we'll go bring this utility up. And then for scale out, we have a separate utility because the scale out designs work a little differently. And so there's some different sliders here, but the overall form function works the same way. So let's say a customer needs 30 petabytes. We just put in 30 petabytes, and this draws out all the hardware that's required. And then you can see this started off at 27 nodes, and we'll go to work on designing something to reduce the amount of hardware. So we start adjusting things here. As an example, might use a 16+3 erasure coding, and then use some different chassis that have more higher density. And so here is an example. We got it down to 19 nodes to deliver 49 petabytes of raw capacity. And then, this can very quickly go from a design like this over to, distributor to one of the resellers and distributors, so you can get some pricing information. We also do checks to make sure the design is good. In this area down below, we'll put some red text if there's a problem. And in this case, it's telling us that we need to have more flash storage in this architecture. So I upped the amount of flash storage, and it's now saying it's okay. But yeah, the whole design, all the adjustments we made are right here in the URL. So you don't need to save the file. You just take the URL and save that, or send it to your other people, either at the internally in the organization or to the reseller, and you can make adjustments to it and just send a new URL around. So these are really fun to use, and they give you these nice performance estimates over here as well. So this is how we are able to really rapidly come up with great solutions for customers in just minutes. And then they've got something to take away at the end of the call that they can go look at and match up to their requirements of what they're seeing in their environment in terms of performance needs and capacity needs. We really cater everything to different industries based off of what their requirements are. Some of the things will, between two different industries, like they've got a particular database workload or virtual machine workload, it might be very common across different industries and have a lot of parallels between them. But we, have a very consultative discussion with every customer, every client around what are their IOPS, what are their throughput requirements, how much scale do they have today, how rapidly will they be scaling in the future, and that information points us to either scale up or scale out for the storage pool type that we're going to go design for them. And then it also helps us determine, should we use a hybrid mix of flash and platter or just do all flash? And those are kind of the main things. We want to figure out scale up or scale out, flash or hybrid. And that's kind of narrows it down to, a quadrant. And then we can kind of further dial it in on what brand of server and flash media and things like that. And sometimes they'll have multiple different use cases, and we'll design multiple clusters, but we can put all those clusters into one storage grid. And so everything's just sort of bespoke design for their needs. But it's all using standardized, off the shelf hardware, and it's using the same QuantaStor platform on every server.
Now, does that pertain to adopting new technologies? Like, I'm curious about the role of your architecture and what it plays in enabling organizations to integrate these new technologies as they become available?
Yeah, that's one of the great things about having built QuantaStor on top of Linux is that we get support for all the latest hardware very rapidly. So, like as an example, the latest 400 gigabit and 800 gigabit NVIDIA Mellanox network adapters. We support those today because they're supported on Linux before anything else, right? Those are designed to for the AI ML compute clusters, and so implicitly that's Linux. So being a Linux-based platform, we get a lot of benefits, and we use Ubuntu underneath as the underlying Linux distribution, but we also have options for running it on Red Hat-based distributions for government customers that generally want to use a Red Hat-based distribution for various security features that we get additionally with those platforms, with FIPS compliance and STIG compliance that we get with RHEL-based distributions.
Okay, now you don't have to, name any names or call out any company in particular. But for my next question here, I'm curious if you have a particular maybe success story you could share where Store really helped a company improve their storage solutions. Like, do you have anything that comes to mind?
Yeah, there's a company on the East Coast that we did a sizable deployment for this year, where we built out a big object storage cluster. It was rack scale, and they replaced like 5 racks of MinIO with 1 rack of QuantaStor. They've got over 6 billion objects that they manage and do analytics on for AI ML type workloads. And then they have over 160,000 buckets. It's a multi-tenant environment, and it just was transformative for that customer to be able to go from the old MinIO with the various challenges they were having with that to a much more dense and higher performance solution from us that could really reach the scale that they need to get to over time. And even where they were at with the 6 billion objects, it was 5 at the time. They were just kind of at sort of like the limits of what that MinIO cluster could do for them. They were running into various problems with metadata performance, which we solved by doing a hybrid blend of Flash media for all their metadata, and then Platter mixed with Flash for all the data storage for the bucket. So yeah, that's a great example of one that we just did last year, and that's what companies come to us for is like, how do we solve these big challenges, these things that are in the petabytes, tens of petabytes of storage and billions of objects. There's a lot involved to go and get those designs right and be able to manage those with ease. And the software, we just build all that intelligence into the stack so that you can use technology. We use technology like Ceph underneath. We use the Ceph Linux file system technology, which is open source, but we build all of our software around it to extend it to make it so that it operates with ease at that scale, and extend the Ceph capabilities with things like intelligent data placement. So we're heavily involved in the open source, but we also kind of take that and I kind of look at those file systems as like an engine in a car, and we really build the entire vehicle. And organizations that just kind of take the engine and kind of try to build their own, solution around it. It's a lot of work, and there's a lot of risk involved because you're kind of manually working with the engine directly versus just getting in the car and driving it. So that's kind of the difference with a software-defined storage platform like ours versus just installing Ceph on Red Hat or something.
Yeah, that's a good analogy to illustrate that. I imagine there's just no shortage of different like success stories you could share, and I think just generally speaking, the bigger the organization, the bigger the impact you have on them, and just ultimately the end user, right? Whether they appreciate it or not. I think that's really what's interesting about working in the B2B space is like at the end of the day, you're impacting the end user, but there's so many behind the scenes components at play that so a lot of people just don't realize unless they're or appreciate unless they're listening in to a podcast like this. So it's really fascinating, enlightening. Looking ahead, though, I'm curious, like what are some upcoming features or updates or changes customers can expect from QuantaStor? Do you have any particular exciting features to share? Just curious to hear anything that's currently in the works.
Well, we just this week we're shipping QuantaStor 6.5, which introduces ransomware detection. That is super important to be able to like detect anomalies, anomalous behavior in the environment, and so it's got an auto learn mode. You turn it on, and it goes and monitors the type of activity that you have, and then after some set amount of time, it will usually a week. It will then go and start alerting if it sees something that is anomalous. So if you've got a whole bunch of file deletes or a whole bunch of modifies in a particular folder that you've got the active ransomware monitoring turned on for, you'll get notified. And that can be really, really helpful for getting early alerting on, something that's going wrong in the environment. We also have, for a long time, we've had immutability both for file storage, write once, read many, as well as object. And those are also really critical for ransomware protection, because if the files do get modified, you've got older versions of them on the system that you can go and recover from. So that's something I think every company really needs to have a look at, is like, what's the fallback plan? Where's the air gapped copy? How recent is that? As well as, do I have immutability and other things in my environment, so that in the event of some type of ransomware or malware, any type of cyber attack, you got a rollback strategy that you can go and get the business back up and running in minutes or hours.
Yeah. Ransomware attacks are really just only increasing, it seems, and especially with all these different AI tools being able to increase the phishing attempts. And I mean, it seems like every day there's a new data security breach for either a widely known, large consumer facing company, or a company behind the scenes dealing with large amounts of customer data. It's troubling. What would you say? Like, could you talk about some of the security components? How much of importance do you stress with security in your product?
Yeah, one of the core things is in any storage product is to have a role-based access control system. And what that does is it lets you create a role that only allows that particular role to do a limited set of things. So let's say you had some administrators in your environment, and all they need to do is create network shares to share out file storage. You can, in QuantaStor, go in and into the web UI or use our command line utilities to create a role that says share administrator, and give them just the permissions to do just that job function. And that's really important. That's sort of following what's called the rule of least privilege. And that way, if somebody got that account and wanted to do something destructive with with that user account, they wouldn't be able to do anything outside of the limited set of permissions that you give them. So we have a really powerful role-based access control in the QuantaStor grid. It's actually patented. And the thing that's really unique about it is that it's not just the role, but the users can get assigned a role, but also get assigned to what's called a resource group, which is a unit of multi-tenancy. And so now you can create multiple tenants within the grid. And that's super helpful, both in the commercial sector, but also in like the research environments at universities and other research institutions, because they've got multiple teams within the organization, multiple departments, sometimes at different sites, and they want to create a namespace for each of those departments, so that they can figure out, okay, how much storage is the math department using versus physics versus biotech, and they can then divvy out the cost of the overall expense for the hardware and software maintenance of the overall storage environment. So the multi-tenancy is both super important and for the security aspects of it, but also important from the chargeback. And that's one of the other key things that QuantaStor has that helps it differentiate in the market.
Where do you see the future of this space going? Like specifically in regard to the software defined storage space, where is it going? What role will your company have in sort of driving innovation in this space?
Yeah, it's an exciting space. I think that the environments are just getting bigger and bigger. It used to be that a petabyte was a lot of storage, but nowadays a petabyte fits within a single shelf. As an example, Seagate makes a unit called a Core Vault that holds 2.5 petabytes of storage, going to 3 in one shelf. And so managing storage at the exabyte scale is the exabyte is the new petabyte. So we're really focused on a lot of features to be able to go manage things at that scale. And what we see is more and more organizations really operating like their own private cloud, like their own Amazon, and offering their own object storage and other services within the organization. Because it's just trying to put those workloads into the public cloud is both really expensive, and you can't really separate your compute from your storage when you're doing AI, ML, and other types of workloads. They need to be right next to each other. And if you were to go move all of your compute and all of your storage up into the public cloud, now it just becomes prohibitively expensive to go do that research. So on-prem multi-tenancy is super critical, but also the ability to get to greater and greater scale is really critical, especially when you take a look at the type of work that's being done today with the AI revolution that's happening.
Yeah. Yeah, that's actually a great segue there, because I love talking about all the different emerging trends, and artificial intelligence is, I mean, at the forefront of it all, right? That's the $1 million question: is where the industry headed, what emerging trends are coming next. With that said, where do you see, like, what's the biggest impact you see on the enterprise storage industry in the coming years? You kind of touched on it in the previous question and answer, but where what emerging trends going to have the biggest impact, broadly speaking?
Yeah, I think things are fairly incremental. I don't. I look at it like it seems like every few years there's another core thing in storage that becomes table stakes. Like you just have to have it. And right now that is ransomware. I think looking forward, it's going to be more and more integration and features that are going to go serve these AI ML type workloads. Right now, what we're seeing is kind of a high performance file system tier for those AI ML workloads, and then a high performance hybrid storage tier that's a mix of Platter and SSD or NVMe, that's object storage, as where you move that data after you've built the models with it. So there's kind of a two-tier architecture and kind of the integration between those tiers, and I think a lot of the requirements for these future storage systems and how QuantaStor evolves is going to be driven a lot by the demands of that market segment around AI ML.
Okay. Yeah, it seems like your product it's future proof in a sense, like that it is the emerging kind of trend in technology, separating the storage from the hard, or the brains from the hardware body.
Yeah, and it lets us partner with a lot of different, like GPU Direct. There's these various products out there that will use GPUs to do hardware RAID across NVMe devices, and we've partnered with a few of those companies. One of them is like Great Technologies, and QuantaStor just layers over those. And as new hardware technologies come out, they almost always design for Linux first, and so we are always evaluating those things and saying, hey, is that a good thing to pull into the QuantaStor platform? So we're just kind of constantly evolving the platform to kind of use the best of what's out there to go make the most cost effective and high performance storage solutions that we can. Sometimes things that come out new, like one example is NVMe over Fabrics. We were one of the first companies to integrate with NVMe over Fabric, some of the product from Western Digital, but that's still evolving. I think that's one of the things that I think is going to catch on a lot in the years ahead, because the cost of the 100 gigabit Ethernet networking is now much, much lower than it used to be, and NVMe is so pervasive. It's the standard for flash storage today. That I think that some of the composable architecture things are really going to pick up over the next few years. Whereas we integrated with those kind of early and then didn't see the adoption early on. I find that so often we'll go and build technologies, but the kind of the adoption curve, sometimes we're on the up upside of that, and we have to wait before something becomes really important. And another example of that is multi-tenancy. All the multi-tenancy stuff that we're talking about today, we really built that into the architecture of QuantaStor 10 years ago. And then I was like, why aren't people using this? And then, 5 years later, now you start to see the adoption and requirements for multi-tenancy really come about.
Huh. Yeah, that's really interesting. Yeah, it's one thing to have a new technology kind of hit the marketplace, but it's a whole other thing to see when it's going to actually become commonplace. I mean, you look at even like the some of the AI chatbots nowadays. I still have frequent conversations with people, mostly my family members who have yet to even really experiment with, say, ChatGPT, for example. And I'm like, what are you doing? This is the future here. This is the next big thing since, I mean, the advent of the internet, right? You got to be starting to play around with it, and you don't have to use it for necessarily like work related um, tasks. You could have it formulate a workout routine or something for your everyday lifestyle. But another thing too is, a technology that I've kind of is always fun to read about, and it's in the distant future, kind of in the same realm as like quantum computing, but it's storing storage on the kind of biological cellular level. Have you looked at that much, like being able to kind of like write um, petabytes of data on like a DNA strand or something kind of on that scale?
Yeah, I have a friend that's an investor in one of those companies, and I haven't chatted with him about it in a while. But I find that fascinating, and I think that's those technologies are that fundamental science on, like, okay, we've been storing it on platter storage, hard drives for ages. And they constantly, like Seagate and Western Digital, constantly coming up with new things like Seagate's hammer technology and being able to write in layers eventually on the hard drive surfaces. But the DNA stuff is just sort of like a whole new way of storing it, but also storing it for thousands of years. And when you think about, like, as humanity produces all of this data, how do you ensure that all those images and videos and content and research and discoveries are going to be around forever? It's things like DNA storage. You put it onto that. As long You also have to make it retrievable, right, in some way that's robust for thousands of years. So you have to think about that. But that's what the kind of research that those teams do. But I'm excited about that. I think that we don't want to be in a situation using the kinds of technologies that we have, 50 years from now, because hard drives wear out, SSDs wear out. You kind of like have to plan to replace those every 5 years. It'd be fantastic to have that type of performance and then some, but on our archival grade type of stuff where you write it, it's going to be there. If you go and take that hard drive or whatever that future media device is, SSD type or something, and you put it in a drawer, you want to be able to take that out of the drawer 20 years later and know that all that content's still going to be there. If it's your family photo collection or whatever. And the technologies we have today aren't that robust. So yeah, the DNA stuff I think is fantastic. And there's a bunch of other things that are archival grade media that are under development that are like that as well. So it's exciting times.
Yeah, yeah, that's it's neat to see, some people are kind of really starting to work on the next big thing, and even if it's going to be still decades out. How I mean, not to get too in the weeds with this subject, but I mean, what would your educated guess be for the timeline of when we might see like wide scale adoption of maybe some of these DNA biological cellular hardware storage?
Yeah, I think it's so hard to take things from the lab and put it into production. I think that like SpaceX is a good example. I think that there were a lot of questions about, like, what um, what's the hard part of this? And it's really like in that case with those Raptor engine is building the manufacturing line. You need to make it repeatable. You need to make it consistent, high quality, and to kind of to me, I don't know enough about how you would go and make sort of something that can analyze the DNA chains inside the form factor of like a 3.5-inch box, right? Because usually the new tech needs to fit into the old hardware when it first comes out, and but maybe they are already miniaturizing that type of thing. So I would imagine that there will be sort of large, like it'll start large, just like the mainframes and computers of old were done, and you'll have these specialized boxes that will roll into a data center and take up an entire rack to begin with. But then over time, those things will get smaller and smaller, and then find their way into the consumer space. But I think most of those things are still in the R&D phases of stuff. So I would guess at a minimum 10 years, probably more like 15 or 20. But there's so many different things that are being done in that scale, kind of getting down into that atomic scale of storing data, on different media and materials. There's so much material science being done that it might not be DNA. It could be so many other areas. I think Microsoft was writing data on this glass at some point, and storing it in like a 3D matrix. There's just so many interesting research, so much research being done out there on that. And a lot of these things are like a petabyte in that form factor of a 3.5-inch drive. They're getting that type of density on these new materials. So yeah, it's going to be fun to see the evolution of it all.
Yeah, yeah. Thanks for kind of humoring me with this subject, and kind of going back with what you said. Exabyte is the new petabyte. I love that little like quote there. Well, kind of getting back on track here. As I got to say, as data continues to grow at a rapid pace, it's more important than ever for businesses to update their storage systems with newer technologies. I think modernizing their storage infrastructure is no longer just an option. It's really a necessity to stay competitive in today's just data driven world. With that in mind, what advice would you give to organizations looking to modernize their storage infrastructure?
I would say start with looking at what you have and what your requirements are. If you are using, VMware or some other hypervisors in your environment, you've got archival storage. Take a look at those workloads and figure out, how much capacity are you using, what portion of that is active, and um, what are your IOPS, this IOs per second. Find out what your bandwidth requirements are and your IOs per second that you're using today, so that you know what you need. Because if you haven't done that analysis of kind of like where your bottlenecks are currently, and what areas you want to improve, um, it's hard to go pick things out. But once you kind of know what you've got, then you'll want to kind of figure out, okay, what's the growth rate of our storage, and say, okay, I've got a petabyte today. I've got this growth rate of X many terabytes per month. I'm going to need X amount over 3 years. Because when you build a new system, when you buy a new system, you really want it to be able to take care of at least the next few years, and then be able to incrementally expand that system by adding more nodes or more media to what you've got. So yeah, a bit of planning to begin with, just kind of scoping what's that expected usage, what's your expected performance, and then you've got all the tools to start evaluating different storage options. And we make these tools on our website. That's what I was going to show earlier. For designing QuantaStore based solutions, we have on our website a scale up and a scale out design utility, and you can tell it, hey, I want to use this brand of hardware, and I need X amount of capacity, and you just move the slider bars around, and we help you with that on a call. So when we meet with customers on over Zoom, or we will go and, after learning more about their environment and getting a better understanding what they need capacity and performance wise, we'll come up with a design, and the design tool gives them a URL with the whole design in it that they can then discuss internally, and also take over to their supplier, their reseller, to go and get quotes from. So it's really shortened the whole process, because we can go from a discussion to a design to a quote, so they've got something tangible really quickly.
Yeah, that's great advice, and I want to sit down and kind of see what you're talking about here, and kind of the visual side of things. Um, one thing I want to keep kind of drilling down is really some key takeaways. I want to continue to simplify what you just kind of talked about here for our listeners. If you could boil down that advice the advice you just gave about organizations looking to modernize their storage infrastructure, if you could boil the advice down into one or two key takeaways, what would they be?
Yeah, analyze what you've got to know capacity and performance requirements, and then that and then start looking at depending on your scale up or scale out options. And if you're above a couple of petabytes, you really should be looking at a scale out type architecture where you can keep adding more nodes, storage nodes, to get to whatever capacity and performance that you need. And certain protocols like object storage automatically go to a object store or to a scale out type architecture. But yeah, figure out what you have, and then kind of that'll help you decide on whether or not you should be using scale up or scale out, or a combination of the two in some cases. And use the latest. You want to use a platform that'll get you access to that latest tech, like QuantaStore, so that you can be using the latest generation of NVMe drives and servers, so that your investment is going to last 5 years or more, so that you don't have to go and do a forklift upgrade. And that's one of the neat things with QuantaStore. Our subscriptions include all the software support, upgrades, all that's included. So as the system ages, we're keeping up the software version with the latest stuff. So you get all the latest features, and all that stuff's all included.
Fantastic. Awesome. Well, hey, thanks for breaking that down. And I've got one last final question for you. And that is just, how can listeners learn more about your company and get in touch with you?
Right from our website, you can just email us at sales@osnexus.com to get a meeting set up. But on our website, we give away QuantaStore. We have a community edition. There's a free version that you can set up a scale out cluster up to 320 terabytes. So if you go to our website, you'll find the ISO image and the resources to go get license keys and stuff like that to start using the platform. But yeah, if you email us at sales, we'll get a meeting set up to discuss your environment and learn more about it, and give you some great suggestions on some way to solve whatever storage challenge you might have.
Perfect. Awesome. All right. Well, you heard it here first. Thank you so much for your time and sitting down talking with us about OS Nexus. I really appreciate it, Steven.
Yeah, thanks for all the time, Bo.
All right. That was Steven Umbehocker from OS Nexus, co-founder and CEO. Thank you all for listening to the SourceForge podcast. I'm your host, Bo Hamilton. Make sure to subscribe to stay up to date with all of our upcoming B2B software related podcasts. I will talk to you in the next one.